Another way we can look at geometric sequences is that of using the enlarge or reduce function on a photocopier. So we have a photograph that's 25 centimeters long, and the photocopier that we're standing at can reduce something to 67% of the original. And what I want to know is, if we do that 5 times, we copy it, reduce it, put the reduction on the copier, reduce that, what's the smallest possible photograph we can get? So with this being a geometric sequence, we'll define the variables for that formula. T1, first term with the first photocopy, would actually be 25 centimeters, because we're not actually dealing with the photocopy yet, we're dealing with the original. N would be 5. We're going to do this 5 times. Tn we don't know, because we don't know how long this 5th photocopy is going to be, which leaves us with R. Now, R is not going to be 67. If we said R is 67, that means that we're going to make something 67 times bigger. So we need to deal with that percentage in terms of a decimal, so R is actually 0.67. Go to our formula. Fill in what we know. And it's very important here that we understand what is going on in this formula. Some of you may blindly go and type this into a calculator in one step, and that's not a good idea, because the calculator doesn't understand order of operations, and if you just blindly type this in, chances are you will miss something, and the calculator will think you mean something that you actually don't. So it's always better to do a little bit by hand, knowing that we understand the concept. What we can do by hand is deal with that exponent on the 0.67. Remembering order of operations again, we have to deal with exponents first. Now, we could try to type this in one step, but again, the calculator may not understand what we mean. So instead, let's do it in 2. If we go and we do 0.67 to the power of 4, just that piece, we get 0.20151121. We can now take that, multiply that by 25, and we get, if we round it correctly, that this photograph would be 5.0 centimeters long.